Welcome to Careless Coder. Today we will have a look at this little puzzle called Impregnator. Oh, Frustrator, not Impregnator. Motherfucker! So today we will have a look at this little puzzle called Frustrator, and then we will actually write an algorithm in C to solve this. Because basically it's the NQueens problem, but done with preset queens at a certain position. So let's have a closer look. So this is Frustr8tor. Basically it's NQueens problem. Something that if you studied computer science you're bound to have had in your college courses. Basically you need to put the queens on the board in such a way that they cannot threaten each other. The variation of this is that there are preset queens already on the board. That makes it a bit more complex. The design is actually rather clever and simple. You have your red pieces here and you have these numbers. So if you say, for example, we're going to play 8, then you see, oh, it has 3 dots. So there are 3 switches or sliders that point to 8. And there's the other one. Yes, so they're already set. And then it is up to you to solve it with your yellow pieces. Now NQueens is actually a relatively simple protocol or algorithm, because you basically slide to the point where you cannot be taken. So here I cannot be taken by that one, there I cannot be taken by that one, and okay, now when you move to the next one and you set that to a point where it cannot be taken. So this one is not safe because it can be taken there, so then you move it over. So this looks safe, right? Oh, there we don't have one. And then, well, we could probably do this. Yeah, that is still safe. And then we start to get into a predicament, because here we start to catch this. And then you basically backtrack. So you move that one back and you find a position here that could work. No. Then you move that one back. So you look over here. No. Over here. No. Over there. No. So basically we need to end up all the way back to the beginning. Right, and then, well, you sooner or later already start to see that we're not really getting through here. That will work. But still with these, so we backtrack again. Can we put this anywhere? No, we know that. So basically you go back until you have a situation that works. And in this case, I know that you end up all the way at the bottom, because I did this puzzle. And then this one goes there, and that one we don't play. And that one can go there, I think so, yeah. And this one should be not there, because that one, yeah. And this one there. So this can't be taken, that can't be taken, that can't be taken by anything. Yeah, so that's the solution. So this is really simple to implement in software as well. So here we are, and basically this is the outcome that it's generated. It's written in C. And I actually used some of the code that I used back 31 years ago here in the solve, this part, to check the diagonals. And this time we also have to check the horizontal and the verticals, because we already have preset queens. That is the deviation of the standard NQueens problem that I coded here. Now I should be able to actually deduce what the beginning and the end vector is. But yeah, I didn't. I just iterate simply through the position diagonally on the 4 axes. I couldn't be bothered to figure that out. So we first start by creating a board that is n by n. In this case n is 8. And we set it to 0. This is actually the show board function that will show this. And basically we iterate through the x and the y, or the rows and the columns of the board. And we have a switch statement We'll check if it is 0, then we print this, the white dot, that's what we see. If it is 1, we print the yellow Q, and if it is 2, we print the red Q. And the red Q are the ones that are already set by the Frustr8tor game at the back, which I just showed you. Well, here's the legal move, and the only thing that I had to do was add these two methods because, well, we already had the queens set. If you just solve it without the queens being set, you just insert your queen at the position where it just cannot be taken diagonally, and then you're pretty much sure that it also cannot be taken horizontally. In this case, since we have preset positions, I need to also check horizontally and vertically. So those two I added. And that's basically it. It's just checking the 8 positions of your queen. And it goes rather quickly. It's not the most efficient, but it will work. Is there a piece in the column? I want to know if there is already a piece in a column before actually putting it. And if so, then we'll return true. That is basically because we have these preset queens already in there. And I need to know, in order to move to the next column, to drop the queen in there. And that's the heart of the thing. This is the solve. And it's basically a backtracking solve. What I demonstrated, if it doesn't work, you bring your queen back to the top. You bring the other one next down to the position that it actually is safe, and you try again, and sometimes you iterate all the way back to the first one. There is one of these puzzles in there. And that can be frustrating, but and a human actually is pretty decent at actually seeing these. A computer really needs to backtrack all the way to the back if it's just not working. But this will always solve it, assuming that it's a solvable setup. So I check to see if there is already a queen in there, because like I said, we have these red queens that we have set. So in this case, in column 0, is there a position in column 0? And yes, there is. So we need to move on to the next column. So is there already one in? Yes, there is. So move to the next one. And otherwise, yeah, there's one, so we can actually drop it in. And then when we drop it in, we will check if it's a legal move. So if it is a legal move, then we set it to 1 and we solve it again. If we cannot solve it, then we backtrack to the last piece. And this is a recursive function. It just reiterates. And we recurse this until we have everything solved or 8 positions are used and it cannot be solved. So basically we drop in a queen, we check if we can locate it there, and then we start from the first position. If it's not a legal move, we move to the next position down. If it's not a legal move, to the next position down. If it is a legal move, we skip to the next row, and there we solve it again, basically checking if it's a legal move. If it's not, we're moving it down. If it's a legal move, then we move it there. And when we cannot solve it, then we just backtrack it. So we remove that piece and we move the other one down. So since I wanted to solve Frustr8tor, I needed a simple configuration file and a file parser that allows me to set the first pieces. So basically these are the vectors of locations where the red queens are already in. And you need to end with a blank line because I was too lazy to figure it out. I just wanted a quick read of the file and see it work. So we read in a whole line. A whole line is a maximum of 255 characters, which should be enough since there are only 4. We have the X, the comma, the Y, and the new line, as you can see. And then I clear them out with Kellogg, of course. Always a good practice. So when I read that line, I will print it to the screen. So we have also a visual confirmation. If the length of the string is 4, then we know it's a legal move since we have the X, Y, and the new line. And then I read the second character, which should be the X, because we reverse it, of course, and convert it from an alphanumeric to an integer. And same for the Y, it's on position 0. And I made it actually 1 based, but arrays are of course 0 based, that's the -1. And I just set it in that board. And here I have a little function or little if construction that makes sure that at least it should be a valid number between 0 and 7, or 1 and 8, or 0 and 7. And this is the solution, that's Frustr8tor. So we have the Frustr8tor solution that takes in the board, and it's called here. And it will call the solve on the board starting from column 0. Then it will show the board because it is solved or not if you have a wrong configuration. And then we print the outcome vectors that you see below. And this is the board that is defined as 8 by 8. And here we empty that board, and here we check if we passed in a configuration file for Frustr8tor solution. And then we call Frustr8tor here to solve it. If you do not pass in a file, it will basically run as the NQueens solver. So let's give it a try here. So let's start Frustr8tor, and let's pass in the 8 because we just did that in the introduction. So here is that solution. Let me superimpose the solution that I have come up and see if it is correct. So yeah, the red queens actually match, but that is not the difficult part. Yeah, the white queen, the first one is all the way at the bottom. That is correct, that is correct. Yes, it matches up. So my solution matches the solution on the screen. It works! Let's run another one that I entered. Frustr8tor, let's change that 8 into an 18. And that is the solution for the 18. The A-team, right, Murdoch, the 18. And there's another one. Yeah, it's really working. It's cool. And it solves it a lot quicker than I can. And here without the arguments, and we just do the standard NQueens problem. And it will always be the same, of course, because, well, the first position matches, then you go to the other one, etc. So there will always be a deterministic same outcome.
So there you have it, the impregnator.
The Frustr8tor. I am the impregnator. I may have a couple of illegitimate kids in Canada and Australia. I should have worn a rubber, but yeah. I don't know, they never popped up and claimed alimony, so maybe I'm good. Yeah, this was actually really fun. I played all 27 combinations over the course of a weekend. And that's when I remembered seeing the NQueens problem also on a old floppy, where I had that keyboard sniffer that I did a video on about 2 years ago already. Wow. So I took a lot of functions from that, the solver and the backtracker, and just added to it, and in about 2 hours created the way that I can also put these preset pieces in there and just verify it. And it was really fun. It was sort of a nostalgic rush, yeah. And I do really like these sorts of puzzles. I'm not a guy that likes Rubik's Cube. I adore the Rubik's Clock and Rubik's Magic. And I am a sucker for abstract strategy games. I love those. So in the next video, I actually write an abstract video game, abstract strategic video game, in a browser, which is also a new learning experience for me, because I don't really know JavaScript. I used it a little, but I'm not an expert at it, and I never really dove deep into React, only did 2 little things before that. So to actually write a whole game with drag and drop and an AI was kind of a challenge, and it was fun. Yeah, it's already running. I just need to make the video. I'm a bit lazy. So see you in the next one.